Greetings. This is your tutor, Mr. Zimba. If you are new to this channel, make sure that you like, share, and subscribe. So we are looking at the organic chemistry under the ECZ curriculum, organic chemistry, and we are looking at the formation and structure of nylon. Formation and structure of nylon. So we are going to look at two structures, nylon and also terylene. Nylon and also terylene. So you need to understand that nylon and terylene, these two are formed by condensation polymerization. These two are formed by condensation polymerization, where now water will be given out during the reaction. So these are formed by condensation polymerization, where water will be given out during the process. So when you look at nylon, how is this nylon formed? Nylon is formed when two monomers react together. So nylon is formed when two monomers react together. What are these two monomers? So we have a dicarboxylic. This is a dicarboxylic acid, and we also have a diamine. So when two monomers by the name of dicarboxylic acid and a diamine react together, then a nylon is going to be formed. So what is this dicarboxylic acid? So di means two. So a dicarboxylic acid, this is just a carboxylic acid with two carboxyl functional group. Remember, a carboxylic acid has a functional group which is called a carboxyl group. A carboxyl group is written like this. Structure-wise, the carboxyl group is written like this. Then you have the OH like that. So this is the carboxylic acid. So now, for us to know that it's dicarboxylic acid, meaning it needs to have two functional groups. Then we also have a diamine. Di again means two. A diamine meaning you are having, this is an amine. So you are having two of these amine. They react together to give us a nylon. So now a nylon is also classified as a polyamide because of the bond here. We have a bond here. Sometimes they may ask you to draw where the polyamide is formed. So this is where the polyamide is formed in this structure. So an iron is also classified as a polyamide because of the amide linkage here, the amide linkage which is there. So now, when a diamine reacts with a dicarboxylic acid to give us a nylon and the water. So structure-wise, we have this. Remember, I said an amine has this. An amine is like this, coming from the amino acids, breaking down. So this is an amine group. So an amine, there is nitrogen and two hydrogens. So we have nitrogen and two hydrogens. So since there are two, that's why there's another one here. So we have two amine, which is a diamine, plus a dicarboxylic acid. I said a carboxylic acid having two carboxyl group, two functional group. We have this carboxylic acid and also have another carboxylic acid here. This is called a dicarboxylic acid. So now, when they react, what is going to happen is that the hydrogen from the amine is going to react with the hydroxyl from the carboxylic acid so that they can give us water. So that they can give us water. This is water. Then we just connect the two. So this is the what? This is the amine. It has lost the hydrogen. That's why it's only having one hydrogen here. The other hydrogen is this side, and then we attach the dicarboxylic acid. So this is the structure of a nylon. And remember, I said a nylon is classified as a polyamide because of this amide linkage. This is called the amide linkage. That's why this is called as a polyamide. In case they ask you in the past paper, because there was a year where they were asking the other name for a nylon is what? A nylon is also classified as a polyamide. All right. How is a terylene formed? So a terylene is formed again when two monomers react together. When two monomers react together, then a terylene will be formed. So a terylene is also classified as a polyester because of the ester linkage that is there on the uh, terylene, because of the ester linkage which is there on the terylene. So a terylene is also classified as a polyester. Right. So we have said that a terylene is also formed when two monomers react together. What are those two monomers? So we have a duo, which is just an organic compound having two uh, alcohol functional group, the OH. Remember, alcohols, they have a functional group of OH. So a duo meaning we have two alcohol functional group. Alcohol, they have a functional group of OH. So now because there are two, that's why we are also going to have two like this, the way we have done it like this. So we are going to have two alcohol functional group. So we have a duo plus a dicarboxylic acid giving us a terylene and also water. So both reactions, nylon formation and terylene formation, they give us water. During the reaction of terylene, we have seen water is given out. Even during the reaction of how nylon is formed, water is given out. So both reactions, they give us water. That's why during my preamble, I said nylon and terylene, they are formed by condensation, polymerization. Okay, so we have this structure here. This is a duo. We said an organic compound having two alcohol functional group. Alcohol functional group and alcohol as a functional group of the OH, the hydroxyl group. So this is an hydroxyl group and this is an hydroxyl group. Plus in dicarboxylic, it's the same carboxylic acid that we use even in the formation of nylon. So this is a dicarboxylic acid. So now in the reaction, what is going to happen is that from the alcohol parts, from the duo parts, the hydroxyl will react with the hydrogen from the carboxyl to form water. To form water. Then we just now connect the two. So this is the uh, product formed. This is called a terylene. So this is a terylene. A terylene, like I said, it is classified as a polyester because of the ester linkage here. So this is in case you find the question where they're asking you to circle where the ester linkage is. The ester linkage is there. Then in there we have the amide linkage. So in case you are having challenges with organic chemistry and just the chemistry in nature and these other sciences, feel free to reach to us so that we can assist you. We do both online and physical tuitions. So don't feel free to visit us. Thank you for watching. God bless.